From the table we have 5 rows. From this it has only 4 rows. Our expected time is 4805 plus 3, 5105. 5105 it should start. Zero 7 14 19 it's more yes, 30 seconds. Here we tried with 32, not happened. 35 it happened. So it has taken almost 30 seconds, close to 30 seconds, 05 to 35, maybe 27 or 28 seconds maybe, but approximately 30 seconds it has taken to complete the fast refresh. Since the data is very small, we feel that fast refresh is taking more time than complete refresh. In case of complete refresh, it need not check for anything. Delete the data in the materialized view, go to the base table, bring the data, insert here blindly. But in case of fast refresh, it has to, once the refresh started, it should identify whether log is there or not, go to the log file, read the log entry, go to the corresponding table, check what is the change happened over there based on the log, what it has read from the log file, and then take that change, come to the materialized view, apply that change. Because of these so many steps, it is taking some time. But when we have huge amount of data, high volume of data in the base table, then complete refresh will take longer time, because truncate will take lesser time but insert will take longer time. In that case, the fast refresh will definitely help us. See, now it is taking 30 minutes, 30 seconds for one record. Maybe the same amount of time it will take even for 100 records or 200 records. But if the table, base table is having billions of rows, if you do complete refresh, it has to remove the complete data in the materialized view log, materialized view, and then bring complete data from the base table and insert here. It will take very long time. Instead of that, if you do a fast refresh, the incremental changes may be some 1000 records or 2000 records or maybe 1 lakh records. So 1 lakh records out of billion records is nothing. So in that case, the fast refresh will be faster than complete refresh. So now we have seen the fast refresh which is happening automatically. Now let us see fast refresh in the manual mode. Let us insert one more record. Anyway, we have 3 minutes time. After 51, 54, 54 is already completed. So 51 plus 3, 54 is already completed. So another 3 minutes time we have. Let us insert one more record. We insert 7, G700, and then commit. Now the table is having 6 rows, whereas the materialized view is having 5 rows. The last row is not present. So this will be refreshed after 3 minutes. Now 1 minute is complete, another 2 minutes. Now let us refresh this using manual. Not EMP2, ours is EMP4 in fast refresh mode. PLSQL procedure successfully completed. Yes, last record has come. We have successfully refreshed the materialized view in fast refresh option manually. So manually we have completed this. Next, there is the traditional way of refreshing the materialized view. Before having this dbms_mview package, before this package, we were doing the refresh using alter command. Alter materialized view name refresh fast. Materialized view altered means we are doing a refresh using alter command. Let us see this practically. Let us delete one record. Delete from t_emp where employee number equal to 7. One row deleted. Commit completed. So after this, table is having 5 rows. Materialized view will be having 6 rows. Now let us do a refresh through alter. We are doing fast refresh. Let us check. It is not happened. Alter materialized view name refresh fast. Fast is not happened. Let us try with complete. Yes, complete refresh happened in this method. So when we alter the materialized view, refresh complete is working. Refresh fast is not working. Complete refresh happened, so the changes are applied here. We have one more option. When we alter the materialized view, we can go for complete refresh, start with sysdate. Means it will start immediately. The refresh will start immediately. It will not wait. Refresh on demand and then complete. This is another option. EMP4 refresh on demand complete. We are going for on demand refresh. Now let us insert this record in the table. Inserting the 7th record again into the table. Commit. T_emp. It has 6 rows. This has 5 rows. Now let us do on demand refresh. Alter materialized view MVT EMP4 refresh on demand fast. Direct fast refresh was not happened. Now we will do on demand fast refresh. This also not happened. Complete will happen. This also not happened. refresh complete. It has 6 rows. It is having 5 rows. Alter materialized view mvt_emp4 refresh complete. Complete refresh is also not happening now. Execute dbms_mview dot refresh of mvt_emp4 comma fast. It is completed. So from the package the refresh will always be successful, but through alter command sometimes it is not happening. Maybe because of that they have introduced the package. We did the same thing here also. Okay, now we are trying to create a materialized view with the same name in fast refresh mode. It is throwing error. Name already exists. Since materialized view is a database object and it will be stored in the database, we cannot have the same materialized view name for 2 objects. Same name cannot be given for the 2 materialized views. Now we are trying to create a materialized view on a table where the table does not exist. Non-existing table. See t_emp1. Describe t_emp1. Object t_emp1 does not exist. temp1 does not exist. Now we are trying to create a materialized view on a table where the table does not exist. t_emp1. It is throwing error. Table or view does not exist. So if the base table is not present, we cannot create a materialized view on that base table which is not present in the database. This is one restriction. Now let us create a materialized view with refresh force. We are creating a materialized view with refresh force. MVT5. We just remove this. And okay, we create a new table. Create table t_emp1 as select star from t_emp. Table is created. I think it will not have primary key also. Let us create the materialized view. Does not contain a primary key, so alter table t_emp1, add primary key on employee number. So we add a primary key after this, and then let us create refresh force. We are creating a materialized view with force refresh option with the same 3 minutes. We don't have materialized view log here. Materialized view created. Now, when we create a materialized view with force refresh option, when the refresh time comes, first it will try to perform fast refresh. If it is not possible to perform a fast refresh, then it will go for a complete refresh. But definitely some refresh option will be performed, either force, either fast or complete. We do not have materialized view log on this table. Since we do not have materialized view log, now it will go for complete refresh. Let us select star from T underscore EMP1. This is the data. Now select data from materialized view. Both are having. Now delete from T underscore EMP1 where enum equal to 7, and then do a commit. After this, select data from table. It has 5 rows. Select data from materialized view. Initially it is having 6 rows. So the materialized view is created at, we don't have time. Okay, time is on. So in the next refresh, that record will be removed from the materialized view. That is after 3 minutes. We do not know at what time we have created it. 7:58 we have executed. Maybe this is 7:50, 7:40, 7:30, maybe 7. Approximately 7 minutes maybe. So at least by 10 minutes or 10 minutes 30 seconds it should complete the refresh. It is still having 6 rows. We have used the refresh option as force. As we can see here, force refresh option. So in case of force refresh option, yes, it is completed by 9:25. See here, 7 was there, now 7 is removed. This is 8:59, this is 9:25. In between somewhere it is completed. So it is doing either fast or complete refresh, but definitely it is doing a complete refresh now because there is no materialized view log on this table. That is why it is going for complete refresh. We can confidently say that it is going for complete refresh now because there is no materialized view log. If materialized view log is present on this table, then definitely it will go for fast refresh. The first attempt is the fast refresh. If the fast refresh is not able to perform, then it will go for complete refresh. So complete refresh will be the second option. First option is always fast refresh. So we have seen the automated refresh in case of force refresh also. Next, let us see on commit refresh. Refresh on commit. Refresh force is completed. Now we will do refresh on commit. Refresh on commit. We specify on commit in the refresh option and then start with next interval is not necessary, because whenever we do a commit, automatically refresh will be performed. So we need not specify the start with clause and next clause while creating the materialized view for on commit refresh. So if we use these options, we get error. On commit attribute is incompatible with other operations. So we cannot include the other operations here. So we are performing refresh on commit as select star from TEMP1. Let us take 1. So we don't specify any time interval here. Same name is already there. MV5, yes. Use 6. Materialized view created. MVT underscore EMP6 with T underscore EMP1. Now this materialized view will be refreshed only after commit. Before commit, or there is no time interval, fixed time interval for refresh. Whenever we do a commit after making the changes on the base table, then only refresh will happen. Now let us see. Select star from TEMP1. Let us clear it off. We have this data and MVT underscore EMP6. This has 5 rows. Both of them are having the same number of records. Delete where the record equal to 5. Okay. We are deleting a record from the table. 1 row deleted. If we check from the table, we have 4 records. From the materialized view, we have 5 records. See, we have just deleted, but we did not commit. We can see difference. Now let us do a commit. After commit, if you check the materialized view, 4 rows are present. The changes are applied. Let us perform one more operation. Let us check one more time. We are deleting fourth record from the table. Table is having 3 rows. Materialized view is having 4 rows. Now if we do a commit and then check the data in the materialized view, we have 3 rows. The fourth record is removed from this. So the refresh will happen after a commit. That means whenever there is a change on the base table and when we perform a commit, then only the changes will be applied here. So changes will be applied only on commit after making the changes on the base table. Till that, the changes will not be applied. So this is on commit refresh option. Now let us see on demand. Refresh on demand. So in on demand also we don't use other options. Let us use MV7, EMP7. On demand, select star from EMP1. Materialized view created. When we say on demand also, we do not specify the start with clause and the next clause. So the time interval or the refresh frequency is not necessary. Means we will be doing the refresh on demand as and when it is required. Manually we will do it. That is what is the meaning of on demand. See, now we have created based on TEMP1. It has 3 records. Materialized view is also having 3 records. So initially it will go for loading the data. Refresh will happen at the time of creation. Now since it is on demand, let us delete one record. Delete from T_EMP1 where employee number equal to 3 and then commit. Now if you check the table is having 2 records. Materialized view will have 3 records. So now it is not on commit refresh. There is no fast refresh, there is no complete refresh here because frequency is not set. So this is on demand. So we have to refresh this manually. Let us try. Execute dp ms_m view dot refresh. This is the materialized view name, mvt_emp7, comma, let us do a fast refresh. There is no materialized view log on TEMP table. That is why fast refresh cannot be performed. So let us do a complete refresh. Yes, refresh is completed. Let us check the materialized view. It is having only 2 records. So we have created the materialized view using on demand refresh option. So the refresh of this materialized view in case of on demand is not based on the time interval or not based on the commit. This is based on manual effort. Manually we have to refresh the materialized view whenever we require. So once the refresh is completed, then the changes will be applied on the materialized view. Till that, the changes will not be applied. See here, we refreshed it using complete refresh using the package. After that, we are able to see the changes here. So on demand materialized view also we have seen. Let us go back to our initial types of materialized views. Create materialized view, refresh fast, refresh complete, refresh force, on commit, on demand, and then select. See, we have not used build clause and query rewrite clause, except that all other options we have tried. Let us try build option and then query rewrite option. Then we go for pre-built materialized view. Materialized view build immediate.